Topic 3, Network Protocols and Communication. 1. This is Netlabs Hub, where everything is practiced. All labs are done, problem solved. So this is day 3 that I'm going to teach you about network protocols and communication. That is part 1. This is my course roadmap that I'm going to use. So this is the topic that I'm going to handle: network protocols and communication. In this lesson, you are going to understand what are network protocols and what is communication, what are the elements of communication, what should be present to make communication be effective in networks. So let me be back to my course. So this is the chapter, and within this chapter there are objective and subsections that should be covered for me to achieve the objective. So these are some of the sections that I'm going to talk about. I'm going to talk about the rules of communication. Network also just behave as humans do in terms of communication. There are some set standards and rules that should be followed for effective communication to be achieved. So there are network protocols and standards. So these are generally the rules. And in those rules, I'm going to explain how the protocols and standard organization facilitate the interoperability in network communications. More so, I'm going to explain why protocols are necessary in network communications. Why is it important adhering to the protocol suite? I'm also going to explain the standards organization, the role of standardization in establishing protocols as network interoperability is concerned. Next, I'll talk about the TCP/IP and the OSI model. In summary, the reference models. Third section, I'm going to talk about the data transfer, how data moves from one host to the other in LAN, how data is encapsulated, analogized in a common communication where a message is sent to a person. So this is my section, rules of communication. For communication to be called communication, or to be ruled that indeed communication has been done, there are some of the rules that should be followed. There are some of the components and processes that should be followed. So in networks, what are these rules? Communication fundamentals. All communication methods have 3 elements. These are the elements that should be present for you to mark communication is achieved. 1, there must be the source or the sender. Source, where the message is coming from. Sender, the person who shall receive that message, or the recipient I mean. 2, destination or the receiver. In this section, it can be maybe a node on a network. Also, there should be a channel or media. The path that you are using to deliver the message. In normal communication, you may find that person A in a certain city is sending a message in person B in a certain city. So using a phone, that is a media, then the first person encoding the message, that is the source, then the recipient is the destination. So those are some of the components that should be present to achieve communication in networks. So there are some of the rules, and the rules or procedures or guidelines that manage communication in networks is what we call protocols. So protocols govern on how communication is done. The way we enjoy the power of the networks is through the protocols, which enhances communication. You can see here, let me zoom a bit. You can see this place. This is human communication. The message source, the message is coming from the source. This is the signal transmitted. Transmission medium, it can be wireless or through a media or a cable, that is. Then it comes to the destination. So this happens in human format. But when you come in this section, this is the computerized format, whereby a message is generated, follows the same suit up to the destination. So here we use computers, while in this section human beings are interacted. I'll talk about how we achieve this section. So there are some of the rules to establish this. Protocols are necessary for effective communication and include an identified sender and a receiver. A receiver, as a sender and a receiver must be identified, who will be sending and who will be receiving. A common language and grammar. There are some of the language that you should use. For example, a person, you cannot talk a person who is speaking a language that is far from what you are using. Especially, you are speaking to a Russian, then you are not using maybe a French guy with an English guy. So there is a lot of disparity there. Language barrier tempers the effectiveness of the communication. So speed and timing. Imagine somebody sends you a message, good morning, at 6 p.m. What will you feel? It is not an insult. It is just a message, but it's just that it was delivered or it is delivered at the wrong time. So wrong time delivery renders the message to be useless, and such communication is termed to be ineffective. So speed and timing of the delivery. Confirmation or acknowledgement. Upon once the receiver receives the message, he or she should confirm by giving a response back. So these are some of the rules that have been established to ensure that communication is effective. Protocols used in network communication also define message encoding. Message encoding, this is the process through which a message is generated, packed. Message delivery options. For example, a message is encoded or generated. Yes. How are these options that is going to follow to be delivered? It can be wireless or through a media. There are multiple options for such. Message formatting and encapsulation. Encapsulation means you are shielding that particular data with the other information. So your message should be formatted. For example, this happens when maybe you are applying something, then they tell you that ensure that your documents are in your PDF format. So that is a kind of a message format. And you cannot, if you are sending a video, you cannot give it a format for a message or for a PDF or etc. So message formatting and encapsulation is one of the key areas when it comes to protocols. Message timing. Message timing. The time that you are generating the message and the time it will take to be received. So it should be within the timeline. The message size. Depending on the media that you are using, the size of the message matters a lot. And the urgency also. You cannot send a 10 GB file and expect it to be delivered within 1 minute or 2 minutes. It can't happen. Not unless you are on a strong network. So these are the protocols, and protocols, these are the roles of protocols. They help in message encoding, message delivery options, and also message formatting and encapsulation. Let me just... So that is it. Message timing, message size. So in networks, you can be asked what are the roles of protocols in communication. These are the roles of them, and I have explained them here. So next, message encoding. This is just an expansion of what I have explained, that encoding between hosts must be appropriate format. For example, choose a format that is suitable for the partners involved in that communication pattern. Messages are first converted into bits by sending the host. So for example here, a message has been formatted into signals by the power of the encoder, then it is transmitted here. So remember, cables only work with bits, so your message will be converted to a format that is suitable with the media for it to be transmitted. The destination also must have the capability to receive and decode. Decode is the opposite of encode, so that it will be checking the information that is there and it decapsule it in order to interpret what the message intended to. For example, next, message formatting and encapsulation. This just a simple analogy is like taking something, then wrapping it into an envelope. That is a kind of encapsulation. There is an agreed format for letters and addressing letters, which is required for proper delivery. Putting the letter into an addressed envelope is called encapsulation. In network, it's like you are taking the main data, then you are putting a PDU, protocol data unit, that will give the recipient more information. Where was this message coming? Where was the source of the information? Who was intended to receive? And what type of the message it is, and in which format is the message in. So those are some of the information that is under the message formatting and encapsulation. So message size, remember, humans break long messages into smaller parts or sentences. Long messages must also be broken into smaller pieces or chunks to travel across a network, and this one enhances communication to be effective. So each piece is sent in a separate frame. Each frame has its own addressing information. A receiving host will reconstruct or restructure the frame to get to know what the intention was. So this is an analogy or an example of such. Message timing. We've got access methods, flow control, and response times. If, for example, you call someone and your connection is not well, then you will have what to call response times, and there will be some message or information will be lost alongside, and such will turn to be ineffective. So the access method also determines the timing of that particular message. So hosts on a network need to know when to begin sending and how to respond when collision occur. So this one, there are some of the mechanisms at the data link layer, whereby the collision domain, collision detection, and collision avoidance. So those are some of the techniques or mechanisms that are used on media to ensure that there will be no collision, and if at all collision happens, what are some of the remedies? So flow control. The source and destination host use flow control to negotiate correct timing to avoid overwhelming the destination and ensure information. This is in a normal environment that, for example, when you are eating, you must have just to swallow what your mouth is capable of holding and chewing, or else it can choke you. So same applies to network. You will just send that message that is worthy the media, that is worthy the power of your node, the source node, and the power of the recipient node. So that is it. Message delivery option. This area is of key interest when CCNA 1 is concerned. We've got types of delivery option. A message can be sent to one, means there is one source and one sender. In such delivery, we say unicast message. Uni means just one. Then a message also can be sent from one source to a dedicated group. For example, here, you can see there are 4 nodes here on this network, but 2 of them are dedicated to receive the message from this source. So in that scenario, we call it multicast message, or one-to-many delivery. So in a scenario whereby a message comes from one source, but it is dedicated to be received by all the nodes on that network, that one we call it one-to-all or broadcast message. So these terms You should understand them as time goes by because they will be of value in the upcoming courses. Unicast, multicast, broadcast. Unicast, one-to-one. Multicast, that is one-to-many. Many means more than one, so when it comes to broadcast, one-to-all. So you can see those are the diagrams for that. So next section, network protocols and standards. So in this section, I'm going to talk about what are these network protocols, example of them, and what are standards, and what are these bodies dedicated in managing and creating these standards. Because in networks, imagine if every vendor had his own style of maybe doing things. Do you think we could arrive at what we are having at now? I don't think. So there must be patterns for all vendors to follow so that we can get something that is compatible. That's why you can get, for example, if I can just use this, you can get the normal USB, type 2 USB from HP, from Dell, from Acer, or from Toshiba, and all of them, they are just compatible. Why? Have you ever asked such a question, or it is just about the need to use that USB? The reason behind that all the companies are following a certain pattern to achieve something that is human friendly and consumed by all people irrespective of their nature or their brand. So rules that govern communication. Protocol suites are implemented by hosts and network devices in software or hardware or both. So these protocol suites can be implemented by host either through software format or hardware format. So for example here, content layer, conversation protocol suite. One, use a common language, wait your turn, signal when finished. This is like instructions that are maybe in software. Then these are the rules. You can see where is the cave. This is the analogy that has been used to explain this. So the protocols are viewed in terms of layers, with each higher level service depending on the functionality defined by the protocol shown in the lower levels. So there is interdependency between the layers, that the lower layer depends on the higher layer. So in this format, you find that all the protocols are captured in that way to ensure that they achieve what we call effective communication. So when we come to network protocols, general network always functions on the aspect of internet protocol, that is IP. And such, IP is the engine on which the network is based. For example, networking protocols define a common format and a set of rules for exchanging messages between devices. For example here, when I base on this particular topology here, this source is saying that I will send this message across the network using an IP version 4 header. Then I can forward this message because I understand the IP version 4 header, this router here. This router says that I can accept the message because I understand this. So these are some of the underlying rules that should be followed for this message from this section to reach the server here. So the message is the data. Then the protocol that is helping to achieve all this is the IP, Internet Protocol. And Internet Protocol is the main key. That is the engine for networking. So some common networking protocols are Hypertext Transfer Protocol, HTTP. This is for web browsing or accessing services through the web. We use this protocol. We've got Transmission Control Protocol, TCP. This is used for transport and other things I will elaborate later. And we've got Internet Protocol. So these are part of the network protocols that are commonly used. So in this section, protocol interaction. Communication between a web server and a web client is an example of interaction between several protocols. I told you, when you hear web browsing or web related, just think about HTTP. It's an application protocol that governs the way web server and web client interact. So web client sends requests to the web server renders the responses through the web browsers to the web client. And this is the structure. The layer, we've got application, transport, internet, and network access. So these layers, the whole of this is called TCP/IP. It is called internet model. It has 4 layers. As you can see here, we've got application layer. The application layer of the internet layer, the internet model is composed of three matched layers from the OSI model, Open System Interconnection model. So I'll talk about that. So TCP, transport protocol that manages the individual conversation. So this one deals with the web, this one deals with the transfer, then this one deals with the encapsulating the TCP segments into packets, assigning IP addresses, and delivering to the destination host. So these are the protocol that you should understand when it comes to net protocol interaction. So we've got Ethernet. Ethernet works at the network access. This layer here composed of the data link and the physical. So you can see there is a predefined structure. So without following it, you cannot achieve. And that is how protocols interact to achieve effective communication. HTTP is used for application that are web related. TCP is used majority for transmission. IP, its role is encapsulation, packet delivery, IP assigning IP addresses and delivering to destination. By that I mean determining the path for packets. Ethernet, it manages now the transmission of bits on media to the end clients. So this course will only cover protocols of TCP/IP. So this protocol suite is what we call internet model here. So we've got 2 models, and all those 2 models are the ones that support us when it comes to this kind of topic. So we've got protocol suites and industrial standards. That is why all products, irrespective of the vendor, are compatible. If you take a smartphone from Samsung, from Apple, or from whichever company, it will just help you to communicate. It will work the same. Maybe quality and brand as per your preference, but the real objective of that is the same. So it follows certain protocols, suites, which are protocols that work together to provide comprehensive network communication. As you can see here, I'm just still expounding now the internet model or the TCP/IP model, that the application layer, these are the protocols that are there. And this protocol, we've got HTTP for the web, DNS for the domain service, that is where IP is assigned to a certain name, because human memory remembers names better than the numbers. So we've got DCP, Dynamic Host Configuration Protocol. This one is used for automatic IP address assignment in local area network. And also it's part of the way that helps the system administrator to manage networks comfortably. We've got FTP, File Transfer Protocol. This one is also an application layer protocol that is used to transfer files, or you can use this to transfer files either remotely or in time. So we've got this one, ISO based. We've got these protocols, Apple Talk. We've got this Then Novell, Netware, we've got this. But this one is the current standard that we are using. When we go to transport layer, we've got TCP, UDP. So this is the main. When you come, these protocols are further classified either TCP based or UDP based. TCP based means that transmission should be reliable, connection oriented, error free. So protocols that follow under TCP have the ability to acknowledge whether the message that was delivered to the destination was okay or had errors, and if it had errors, retransmission happens. But when UDP does not check that. It considers fast delivery, so you find that DNS is working under UDP. So IP is also working under UDP. You can read about the protocols that are under UDP and those particular protocols that are under TCP. So when you come to the internet, we've got two main, the IP version 4, then IP version 6. Then Internet Control Message Protocol. This is like an echo protocol that confirms that indeed there is communication. When you come to the network access, we've got Ethernet. Ethernet is the main protocol there. So this is the layout, how protocol suites are categorized and bundled. So the TCP protocol suite is an open standard. The protocols are freely available. Freely available means that anyone can use and customize them to their own specifications and utilization. Any vendor is able to implement these protocols on their hardware, on their software, and that's why there is interoperability in between or among the manufacturers. So development of TCP, we've got TCP is developed by ARPANET, that is Advanced Research Projects Agency Network, was a predecessor to today's internet. ARPANET was founded by the US Department of Defense for use by universities and research and laboratories. So during this they achieved this, and it has now evolved to what we call IP. So this is the protocol suite that now I am talking about. We've got application-based protocols, name system, translating names to IP to domain names. We use DNS, domain name service or system. Host configuration, we use boot TP or DHCP, but here DHCP is the common. On email, we use SMTP, simple mail transfer for transferring. We use POP or IMAP. File, we use FTP and TFTP. Web, we use this. On transport, it's either we go the UDP way, where we need faster delivery without any acknowledgement. In this, when you are using this, there is less overhead compared with this. So this is reliable, this is not reliable, this is faster, this is not faster, because it ensures the message is received by the recipient. So when you come to the internet section, we've got IP and NAT. So IP support, we've got ISMP, then routing protocols. These are dynamic routing protocols that help to forward packets dynamically or determine how packets will flow in their network automatically. So communication process, when sending data from a web server to a client, the encapsulation procedure will be as follows. The web server prepares the HTML. HTML is a hypertext markup language used by web. The HTTP application layer protocol sends the data in terms of HTML to the transport layer. Then the transport layer takes that data and breaks the data into segments and identifies each. You see? The next IP source and destination address are added. So the information that is added on the message is called what? PDU, Protocol Data Unit. So Once it adds the IP source and the destination addresses on this particular message that came from the application layer, then such becomes the packet now. We call it the IP packet. At the transport layer, we call it the segment. At the application layer, we call it the data. Then, after there, the next IP source and destination are added, creating this. The Ethernet information is then added. So Ethernet is added at which layer? That is the network access. In this section, that is where Ethernet is added. So at that point, we call it frame. So this frame is delivered to the nearest router along the path towards the web client. Each router adds new data link information before forwarding that. So all this process is what we call communication process. And you can see there is a lot of encapsulation here, because when message moves from one layer to the other, it is shielded with a certain kind of information there. So TCP communication, when receiving the data link frames from the web server, the client processes and removes each. So now the client, its role is to decapsulate the message that was sent. It removes, it strips off. First, the Ethernet header is removed, then the IP header is also removed, then the transport layer header is removed. Finally, the HTTP information is processed, and the HTTP information here is the intended data. So after that, we've got open standards. These are the standards that are managing the protocols on the network. We've got open standards, meaning they are there, anyone can use them. So such encourages interoperability. Interoperability is just the mutual interaction among competitors, whereby one product from one vendor can just be used by the other vendor, or people from different regions can just utilize the same service irrespective of the location, of the vendor, of the format, whichever. So we've got IEEE, we've got IANA, Internet Assigned Number. So this one is what deals with the IP addressing. We've got IETF, Internet Engineering Task Force. This one is what deals with the management of the internet infrastructure. We've got ICANN here. We've got ITU and TIA. So these are some of the open standards that you should understand as a network engineer, and their role, and where are they based, what do they do. So standard organizations are usually vendor neutral, non-profit organizations established to develop and promote the concepts of open standards. So these are some of the families of open standards that come up with the rules or the protocol suite, so that the manufacturers just have to follow. For example, Internet, Electronic and Engineers, IEEE, this one deals with the electronics, whereby if you are in manufacturing maybe cables, you have to follow a certain standards for you to be accepted on the market, and failure to that, they can revoke your license. So let me go deeper here. Internet Society, ISOC, it promotes open development and evolution of internet use globally. We've got Internet Architecture Board, it manages and develops the internet standards. We've got Internet Engineering Task Force, it develops, updates and maintains TCP technologies. You can see that. So we've got the IRTF, Internet Research Task Force, focused on long-term research related to Internet and TCP IP protocols. We've got ICANN, Internet Corporation for Assigned Names and Numbers. So this one coordinates IP address allocation and management of domain names. So generally, we've got IP version 4, and that IP version 4, there are some of classes. So this one determines which class is which and what does it do, so, and who uses them. So that's the role of the ICANN. So majority of the ISP relies to this. regionally or continent-wise. We've got IANA, Internet Assigned Numbers Authority, manages IP address allocation, domain name management, and protocol identifiers. So we've got ICANN and IANA. They work one-on-one here to achieve IP addressing and domain name management. Electronics and Communication Standards, we've got this one. Institute of Electrical and Electronics Engineers, dedicated in advancing technological information and creating standards in a wide area of industries, including networking. We've got Electronic Industries Alliance, related to electrical wiring, connectors, and network racks. So in this section, if you are a manufacturer in electric wiring, there is a standard of a certain, the standards that you should follow while manufacturing your wires, connectors, like a connector like this RJ45, there is a pattern that you should follow. If you fail to follow those patterns, then easily to be revoked. Telecommunications Industries Association, standards for radio equipment. This one manages the cellular towers, voice over IP devices, and satellite communication. So for you to install your satellite, you have to get permissions from these guys. So these are some of the open standards that you can use or you can learn about it, how they work, where they are based, etc. So there is a lab research network standards here that I'm not going to go through it because of time. I'll talk about this, the benefits of using a layered model. Why do we opt to use a model that is layered? One, it assists in protocol design, since protocols at each layer have defined functions. So generally, layered model helps in assisting in protocol design. Two, it helps to foster competition because products from different vendors can work together. All this statement stands to interoperability, preventing technology changes from one layer from affecting the other, also providing common language to describe network functions. Next, this is the OSI model. You can find that the OSI model is totally different from the internet model, whereby these three layers here are bundled to form one application layer. Then the two layers downwards, 2 and 1, they form the network access layer. These are the roles. Application, it contains protocols used for process-to-process communication. Presentation provides a common representation of the data. Session provides a services to the presentation layer to organize its dialogue. It opens session, terminates session upon data sharing. We've got transport, defines how the data will be transported, then network determines the flow of the packets, etc. Then the data link, exchange of frames between them. So this is one of the crucial models that you should not miss, and a question on OSI model will never miss in CCNA exams. So it's a part of analysis here. So you can see TCP IP application 1. This application composed of the last 3 layers of the OSI model. They can ask you now compare TCP IP model and the OSI model. Those are the differences that you will see. The network access here is composing the data link and physical of the OSI model. You can see even a comparison has been made here. So these 3 bundled into this. These 2 are bundled into this. So this is a lab here, a web client to a web server, which I will do in the packet tracer. Message segmentation, data transfer in the network. You can see the message is segmented, means large streams of data are divided into smaller streams so that at least can be suitable for the channel that is being used. We've got protocol data units. the information, extra information that is added to ensure that the message reaches at the sender the way it was intended to be. So first, at application layer, we call it data. Then transport, we call it segment. Then network packet, then data link frame, and on physical layer, we call it bits. So this is an example of encapsulation. Data is divided into segments. The TCP segment is encapsulated in IP packet. The IP packet is further encapsulated in Ethernet frame. When it reaches to the sender, the frame is de-encapsulated. Those particular PDU, protocol data units, are stripped off to ensure that the intended message is left for the recipient. So the encapsulation process works from bottom to up, while encapsulation process works from top to bottom. So those are the key highlights that you should understand when it comes to that. We've got data access, network address. For example, for you to access data in this server here, you should have what we call network address. And the network address composed of the source, where the information is coming. For example, PC1 is having this number. This is the source IP address. Then this is the destination IP address. So that is what is being talked here. And the packet is, this is how encapsulation is done. Data link address, you can see how data link is done. Destination MAC address, source MAC address bundled together, source IP, then destination IP. Devices on the same network. So the network layer addresses or IP addresses indicate the original source and final destination. We've got the network portion and the host portion. So the leftmost part of the address indicates the network. The IP address is a member of host portion. The remaining part of the address, that's the host portion. So I'll show you. For example, in this section here, this is class C private IP address. So 192.168.1 from 1 up to 192. This section is the network part. From .1 up to 110, that is the host part. So that is it. Devices on the remote network. Sending to remote network. Generally, for you, data access on remote network relies on the functionality of the default gateway. You should have to understand where the default gateway is or the nearby router that you will forward your request to, so that at least it can link you to the server that is hosting the resources that you are in need. So in this section, for example, this person will forward the request to this router, and then this router will have to forward here using the default gateway up to the intended recipient. So this is the end of this particular chapter, and this is the chapter summary. Installing Wireshark to capture data, and upon doing that, this is the basic LAN. You can see this is the internet ISP, then this is the default gateway, then this is LAN. So generally what we learned in this particular chapter, that by now you should know how to explain how rules facilitate communication, explain the role of protocols and standard organization in facilitating interoperability in network communications. Also be in position to explain how devices on a LAN access resources in a small to medium size network. So that is it. Let me do a simple lab here. For example, take this to be the ISP, then we can take that to be the internal router, also serving as the ISP, because an ISP can bring the service up to this router, and then this router is now within the LAN. It will serve the internal nodes or internal clients. So take 2960 switch. I'm just configuring this for the purpose of this particular project. So connect that one, that one, then that one. So I will change this because this one cannot withstand the traffic generated by these three computers. So this section 192.168.10, that is the network part, then .00 means the host part, so /24. So this interface gigs 0/0, no, enable config terminal hostname LAN router 2, then interface gig 0/0, no shutdown, IP address 192.168.10.1 255.255.255.0 and config terminal. Then I'm going to create the DHCP pool LAN default. That is the default IP, and then the network is 192.168.10.0 255.255.255.0. Then DNS server is that one for Google. Then domain name is netlabshub.com. So exit. Then I'm going to reserve my IP, first 100 IP addresses. This is how we reserve IP DHCP, exclude, then from the first IP address to the 100, that is 10.100. So let me save my configuration, copy, run startup. So my configuration are saved. So I expect these computers to receive IP address automatic from my DHCP server, which is the router. You can see same applies here. It is able to receive the IP address. You can see this one, same applies here. So when I come to this piece 2 to communicate with the piece 0 here, it will follow the protocols that we've discussed here. It will follow this layout. It will follow this particular protocol. So when I come to this section, then I'm trying to communicate. Let me demonstrate by pinging. Ping 192.168.10.101. You can see. So this message is going, when it reaches this section, it will be stripped. All those particular protocol data units are added. When it reaches here, they will be removed to remain with the data that was intended. So the guideline here is the router, which will determine how that packet will flow. So thank you for following. Thank you so much. If you feel you are so much helped, feel free to subscribe to Netlabs Hub. I'm free to collaborate, to share knowledge using all the resources available. Thank you.